Hello, welcome back, PlayBASIC coders. Let's check out the current, probably last build of PS3D. So, latest additions are Vertex-based lighting. You can kind of pick the object you want this to apply to. In this case here, it's objects are placed into a separate list, and they're all processed regardless whether they're on screen or not, actually. So these toruses here are being updated, the walls as well, actually. The boxes and the dragons are all part of that process. So what's really doing is for every vertice we're running through, and we're defining a couple of lights that have a cumulative effect of how much light is falling on each vertice. So to do that, we need normals. So another new addition is a way of calculating vertex normals for the objects. Before, there was no support for it at all. So to color the vertice, we're grabbing the rotated normal, grabbing the direction of the light, doing a dot product, and going, okay. That gives you how similar the two angles are. So things that point towards each other are going to be lit. Things that point directly at each other will be lit the most, and things that point away will be lit the least. And we're doing a bit of a blend here too with the ambient color, trying to fit it all together. It's not correct. It's just like a hack. It's like, oh well, that seems to work okay. That's pretty much what's been doing. Fixed a few more bugs with PV, of course. I don't think any others have been reported. No one's been doing anything, so no, why would they be reported? Of course not. The outside stuff still exists as well. There's no partitioning of space or anything like that. Which anything in the world is being processed and thrown through the camera. There is some frustum checking happening, of course. Things like objects that have lighting applied to them, they're being processed regardless. It's not kind of, I've sort of slotted it in as a side effect, as opposed to something that an object in here can actually have. Like, to round this out in terms of the PolyWolf stuff, I think we're just missing interpolation animation of the frames of these MD2 objects. And that didn't have lighting as such, it was just depth cued. So here we've really, well, you can light the scene the same, you're just applying an ambient light. In other words, each vertex that has an RGB value is being multiplied with the ambient light. When lighting's enabled for each object, you make a list of what lights apply to it, and then process the mesh for rendering, and then you render the mesh. So it's clumsy, but it's doable, and it fits into the existing rendering structure as well. So we don't need to change much really to make it work, which is kind of handy. So we kind of keep the simplistic Vertex objects library, but there's a bit more depth in there if you want to mess around with stuff. I can't say it's all tested and all great and wonderful, because it's not really. It's just the only thing written with this stuff is this. So you're bound to find things that will work differently or give you unexpected results. That's just how bug finding goes. So look, So in here, we've got a few different new functions. So what you're actually doing is you have up to, I think it's set to 8 lights, and the lights are just directional with the color. They're not spatial, so you just set the light as being, okay, there's a light coming from above the world, so anything that, any vertex that's pointing up towards the light will be coloured, whatever this RGB value is going to be. The more lights you have, the more work you're doing per vertex, the slower it's going to be. It's all done in software too, so don't get too excited by the prospect. I mean, it works, but this would need more refinement to make it as efficient as what it could be. So, we've got the set vertex object light, and we've got our light and vertex object. So, for an object to react to light, it needs a normal match. It needs a normal set of normals created from the vertices, from the faces. So, basically, you would set up your vertex list, set up your faces, and then generate the normals from that. If you didn't already have your own set, like if you're loading an object in with something or some other chunk of 3D data that has normals in it, you just pull those in. Fair enough. No need to create them yourself. And all they are is just the direction of the face. So vertex normals are really just think of them as the average of any point that is used across many faces. Think of it like the average of that direction. So they're two new functions. We're passing our vertex object in with how many lights to process that we've set up from here. So it's just give me the structure of the object, give me a pointer to the normals, do they exist? If they don't, reject it, rotate the vertex normals. Once we've got this rotated, we get our number of faces to light and our pointer to the first face in the mesh, and we light them. That's it. So the actual usage stuff is in here somewhere. So here I've just added a thing called dynamic, add this object to the dynamic lights, so I've made an object here this is the little part that builds the building. It just reads in a two-dimensional array, like a Wolf-style array. And if it's a space character, it puts a floor and a ceiling. If it's a dash character, it puts a box for the wall fragment. Anything that's a wall and a ceiling, we're randomly just chucking an object in that at that location. If it's one of 3 possible outcomes, it could be a column, it could be a torus, it can be a cube. So these objects here are added to dynamic lights, which means that they react to light. And because the initial object just has a vertex list and a face list, a mesh, with some basic properties about, when we call things like color, we're running through all the faces and setting the faces to this RGB value. Position, turn, or its location and orientation in 3D space. The texture is the same. When we call texture object, we're running through and sticking this texture on every face of the mesh. Now, I can think about better ways of doing this, but I've just left it very generic here. So when we create an object, it has a pre-generated version of its UV map, and then when we just apply the texture, it's just using those UV map. It's actually customizing the UV map internally. So if you went to replace that texture next, it wouldn't actually work. There's a lot of laborious reasoning behind that. It's the way that the mesh stuff works in Translate Mesh to Scene, the very core of all this stuff in PlayBASIC. because I didn't want to change it and then break existing examples. So anyway, we'll create the object, apply a texture to it, add it to dynamic lights. This little function here, it just keeps a list of these things in an array, but it also updates the vertex normals for this object, which just calls a function. If we follow it through, we go, does this PS3D object actually have a vertex object, which is the core structure for any object to exist in 3D space in this little system? If it does, we call the function inside vertex object library, and this just does straight ahead stuff. We check, is the bank valid? Can we get a pointer to it? Does this object have a vertice buffer or a mesh buffer attached to it? It has to have both. So if it hasn't got both, we just don't do anything. How many verts does it have? If it has less than one, exit. If we have no normals, we call the resize. It reallocates the vertex buffer, copies the old vertice data, if there was any in it, across to the new one, and with provision for the normal buffer as well. So normals are just a triplet, the same as what your normal vertex is. It's got X, Y, and Z. They're just vector 3s. So our vertex structure is really all that data packed into one bank for this particular object. And our mesh data is the same. It's just all the faces of the mesh stored in one bank. I'm using PB banks because that's just the way this is structured. We could, if you really wanted to go further with this stuff, you could have a raw chunk of memory with these structures in it, and then you'd have no allocation at all. You could just bang, read it, write it, chuck it back, whatever you wanted. If we have no vertex buffer, we allocate one. Once we've got that, we've got a vertex pointers and our normals pointers where to write this stuff out to, and we just call normal, which is a built-in function that does this work. It's in the back end over here, so it's just a simple buffer management. That's really all it's doing. We've got a buffer here that holds the cumulative colors from when we're lighting an object. It's when we apply the lighting to the object. There's nothing really to it. They're very simple, but really they're kind of workhorse routines. This is the stepping through to light the faces, because each face type can be a different thing in these meshes now. So we run through a mesh and we're trying to create normal verts from it. It doesn't do anything for point sprites, doesn't do anything for wireframe. For a triangle, we're grabbing the face normal, then we're adding that to the tally of the 3 coordinates that the triangle is made from. Once they're all tallied in all directions, whether it's triangles or quads, we'll run through and normalize them all. And that works pretty well. And it's relatively cheap. So, but cheap is all relative though, isn't it? It's cheap to do that for an object that has a few hundred faces. It wouldn't be cheap to do it for an object that has tens of thousands of faces or millions of faces. So there you go. Look, the only thing I can think of really is to implement something that has internal animation stuff, which is really just the interpolation stuff from that's kind of classic MD2. So yeah, those objects have what they refer to as like frames in them. So what you meant to do is if you want to animate between 2 frames, you you lerp between every vertice in the object, which is not that hard to do. It's actually a built-in function into this now. This one's working a bit differently. It's actually taking a source object, a destination object, because the current concept of this has no concept of frames of vertex buffers. That would be the next thing to implement, I would think. So for every frame you could have a separate vertex buffer. You need some sort of name as well, because NB2 files, they're actually named. Like, you know, running, walking, or whatever. We probably have to have something that mimics that, but that's not, you know, nothing that exciting. Here we're using two source objects and a destination object, and the amount of scale between the two. So it grabs the pointer to the vertex buffer of source object, grabs the pointer to destination of the source object 1 and 2, I should say, and writes them out to scalar, to destination object. So that scalar is a value between 0 and 1. And the classic way you do this is you take source 1 plus source 2 minus source 1 times scale. That's it. But it's just doing that on, you know, a big block of data. Yeah, I mean, these are old functions that have been in PB for years, but they weren't really documented. They were sort of experiments with things, and then they were used in the odd demo here and there. So it's like, well, we can't really take them out now, so they just left them there. I think what it should do here is lerp. Maybe you have like the lerp vertex object frames or something like that, and then have your object and give it framed, like source frame and target frame, and then maybe where the destination frame is going to be. So you'd have like a frame that's always used for a scratch animation, probably frame 0, I guess, and then other frames above that would be basically untouched. Okay, one more time. Zoom around a bit. Oh yeah. I'm pretty happy with it. Pretty happy with all of it. It's all subdivided. That's what's keeping the perspective looking reasonable. I wouldn't say I've gone over. I wouldn't say I've gone crazy with the optimisations, but yeah, it works reasonably well. Use most of my normal ideas in these things. Pretty happy with it. And as you can see, I can create some pretty weird looking stuff. Or pretty stylized looking stuff anyway. It really just comes down to how well you understand it, how well you craft your idea to suit what you can do. It's like anything. That's the problem with all of these kind of development tools, is that the tools themselves have a bunch of limits, and you've got to work out how to fit what you're trying to do in the scope of those limits. That's kind of programming 101, really. Alrighty, that's enough for me. I'll see you next time. Bye.